this week. I've got some videos from Ani Kloppenberg.
Oh yeah, that's what you were saying. It's,
One
of our viewers sent something
tie in a little more electric boating if you wanted to see some of that.
You know, it might make people think cooler.
Let's take a look at some water sports in July.
Right.
As a very first thing, I would like to share with you all the unboxing of our first motor. And the dream to build something electric. The dream starts up here, but it's nice to see something for real. And in this case, our very first part to make things real is going to be a Kostov 11-inch 250-volt version motor made by Balkan in Bulgaria. And it's just come in. That would not be the way to do this. That's almost easy. No more tools needed. Now, the first thing I'm going to say, it's smaller than I thought it would be. I know what it's supposed to do, so it's a good thing. But coming off of the truck and here in the workplace, that's good. I mean, there she is. But I guess they must think, hey, it's an electric motor. What do you want to book? You want us to hold your hand? So, you know, they don't. But we're real happy. So it seems my Bulgarian friends could not find the V-Markt. Hello? You have the batteries? That's the batteries? Very good. Well, we're going to try and put them in my little car. And at least finally I will have my lithiums. Yay! Well, we got the batteries. Don't ask me how they fit in there, but they do. Transport wasn't quite door to door. It was more door to 10 miles down the road. Truck couldn't get here, but there they are. And I managed to get them out. So let's open them up. Pretty much we are getting 3.3 across the board. .3, 3.3, 3.3, 3.3. Now we could kind of do this all day, and I just have been trying, but not that much drift, right?
Electric Speedboat. We have our DC electric setup, Winston batteries, Evnetic salt-on controller, and a nice big Kostov 11-inch motor. Now this is our test demonstration setup. We have the throttle here. As you can see, we have a small battery in the back. We're spinning, baby. We're spinning. So we're showing people what it's all about. We've got a little digital dashboard connections. Be able to see, maybe not. It's giving us real-time Wi-Fi logging. At this time, we're currently at 25 amps and 11 volts. So that's safe to touch, folks. So we're not here to kill anybody. We're actually here to show them that the future is fun. It's new electric, and we're having a great time. Thanks a lot, man.
So here we are with the 1974 Glastron. It's pretty much a labor of love. We've had it now for about a year and a half or so, at which time we also entered in the Build Your Dream EV competition. for EVTV. We were lucky enough to be one of your finalists. Came over to see you, what was it, June of last year. Then came again for the EvCon. Didn't win your prize, went to Brandon Hollinger, who's doing the electric cab over in Pennsylvania. So we'll be interested to follow his build. We've come through the winter with a few extra EV parts. We got most of the system together, actually practically all of it by now, and we are hoping to start testing the boat in the water in about a month or so. We have everything set up on the test bench behind us, so I'll take you guys over there and show you what we got. Well, here's our test bench setup in true to form. We kind of got this idea from you when we visited last June. We saw the double motors for the Escalade on the bench. We figured that once all the parts are in the boat, if something does work or doesn't work, we're never going to know really what is what, because we hardly know these parts. We're seeing everything for the first time. So we figured we'd put it out on here, get it to work. For us, it feels kind of like the 1980s Knight Rider episode where Kit is all laid out. She's alive, but she's not in the car. So anyways, we've got our Winston batteries. We have 95 90 amp hour batteries. We're running at, say, 313 to 320 volts nominal, depending on where we are with our stator charge. And I'll set up and do a little demo. Well, this is the end of the motor setup on the table for now, because for the first time, the motor is going to meet the boat.
Likes to be famous. Raymond.
Ik weet niet of we er nu wel zijn.
Ik ga een foto van Ray maken. Ik zal een masker uitknippen met ogen, die doe ik op. Het zijn allemaal Raymond.
Dat blijft gewoon.
Here is our little testing station. So we have the PowerLab 8, and we have a 5 series pack of Winston 90 amp hour batteries. And then I have 4 12 volt batteries from an electric motorcycle, electric scooter really. They're all in parallel, 50 amp hours each, and so that's 200 amp hours. And then here is an old PC that is running the CSS software that comes with the PowerLab 8. Now you'll see that it recognizes the 5 cells and their respective voltages, and it's giving me a overview. I set it to a 30 amp discharge current, so that's 1/3 of the amp hour rating. And it's showing me a increasing number of milliamps that I have taken out of this pack. At this moment we're at 11,000 milliamps, so 11 amp hours have gone out, all of these. This is a setting I made ourselves, so it has the A123 standard settings, and I put it at LifePo 4 90 amp hour high discharge. What I'm telling it to do, here we'll see the supply tab. So I'm running at 13.4 volts on the regenerative discharge. I'm putting in 40 amps to the battery, well 38 something. It's running at about half a kilowatt. The settings I had to put in to do this are over here. So I told it that we have a battery power source. It's a flooded deep cycle battery, and I'm allowing it to max regen about 42 amps. I need the higher setting than standard, because at 13.4 volts, if I want to take 30 amps out of a 16 volt pack, I need some more amps. But so far it seems to be running fine. On the preset tab, I'm running a pattern. I've told it to discharge unbalanced to 2.9 volts. So it's taking its max discharge rating and it's going down until one of the cells is going to hit 2.9 volts. So on the discharge side, it's regenerative. I'm doing constant current, 30 amps, down to 2.9 volt. And on the balance tab, I have no balancing. This is because I figured out that if you turn on balancing and you want it to balance to 2.8, it's going to start balancing at whatever state of charge you start at. So it's going to start using a bypass and using the balancing leads. I'll show you those over here. So here we have the PL8 set up with its two main leads going to pack. Whoops, the camera crapped out on me there. I was saying this is our pack positive on the 5 series pack of Winston 90 amp hour cells, and pack negative, so they're connected to the main jumpers. Then we have the 9-wire pigtail that they use for cell balancing, and they have these little itty bitty wires that connects up to the individual terminals along the way, essentially giving you a battery management system that's able to shunt small loads as the voltage progresses. So what I was saying is that if you immediately turn on cell balancing, it's going to bypass the charge coming from the main leads, and the whole process is going to be a lot slower because it wants to continually keep the pack in balance on the way down. I'd rather have it max discharge down to a certain setting, in this case 2.9 volts, constant current, and then it does constant voltage until 4.5 amps, I believe, so it's already, we're going to see how that acts. Actually, I haven't had it down to 2.9 volts, so I don't know if it's going to do an immediate shutdown as soon as cell 1 hits 2.9, or is it going to hit 2.9 and then start a constant voltage mode until it hits 4.5 amps, which I set and told it to do. Kind of interested about that one. All the while, it is putting power into this lead acid pack that I have here. And even though it's 200 amp hours, it was kind of full when I took it out of the scooter. So I had the problem that immediately after starting discharge, the power lab would cut back the power because it only used its internal discharge, the lead acid pack being full. So the problem I had was, where do I put the power that I'm taking out of the lithium pack to bottom balance? I can't stick it all here into the lead acid pack. It's going to be full too quickly and limit the current that I can take out of the lithium, because the power lab is so damn smart and it doesn't want to blow up these batteries. So I figured, hey, why not use this free energy that Mr. Winston Chung has sent us from China and use it to break in our motor. So we have jumper cables set up, and here is our little jumper cable connection coming up towards our speedboat, ready to make the plunge, but not quite yet. And a good excuse to show you the interior. So here is, get set up. Here's our Kostov motor. It's an 11-inch motor, through 150 volt, 260 amp continuous rating, up to 5,500 RPM. It's spinning up nicely on about 13.5 volts now. It's mounted with a 4.5 centimeter aluminium adapter plate, which goes straight to an original Volvo Penta bell housing. Volvo Penta is kind of like Merc Cruiser. It's a standard for stern drives, speedboats, and a whole lot of other kind of boats. This bell housing is still off the shelf, so in future we'll be able to put a kit into any boat that runs a Volvo Penta stern drive and we know it'll fit, and it'll fit the original motor mounts as well. Raymond made us up a set that will clamp like the original ring around that motor on the comm section, and we'll still have the original rubber motor mount setting. Now it's had quite a few hours with the basic 12 volt that we, put a charger in connection with that. So possibly you can see it's a nice set, the dark brown chocolate color that Tom Brunke was talking of Hellwig brushes. I think we're kind of getting there. The brushes seem to be seated nicely. Now for fun, we can kind of see in this system of regenerative discharge and running into the motor what our amp ratings are on the different parts of the system. Because for me, that was kind of like interesting part of this experiment, even though it's turning out nicely now. So my software is saying I'm pulling 30 amp hours, or 30 amps rather, out of the pack. So let's see, we have a little DC clamp, put it on to 0, and here we go. So we got 30 something coming out of the pack, minus 30, so that's good. Two things saying the same thing, I like it. We have, let's see, about 17.5 amps going through the jumper cables into the motor. So at, what is it? We can check the supply side. Supply tab. So at 13.6 watts, or 13.6 volts rather, at 17.5 amps, that's what it's taken to spin this motor, unloaded but mounted to the adapter plate and bell housing. Within the parallel battery, how's that doing? We have about 5.96 amps. So this would be the net result of the 30 amps that I'm putting in, the 17 something amps I'm taking out, and this is what it'll show in the back of the pack where I'm parallel connected. Now this number is telling me I'm fine because the individual batteries not parallel connected were rated at something like, I think they could do about 500-600 amps discharge for pulse, and they could do about 15 amps continuous for charge. Since I have them in parallel, I figured we'd be okay. But now that we have the whole setup where they're also running the motor, I think we're well within operational parameters. Not that I really know anything about batteries, but you want to be safe or fake it along the way. What else do we have? So this is the high voltage board we had on the table. Everybody will recognize this light object shunt. It's a 1000 amp shunt, and we're not really going to do more than 550 on the battery side. So I think we're going to get, well, I'm looking at a 750 if they have it, otherwise we'll do the 500 probably. Here's our positive side. We've got the last contactor. We have 2 fuses on either side. They're a nice mounting point anyways. And then we have our fuses for DC converter and charger. Nothing's connected right now, so we're all finger safe here. This is what remains of our low voltage board. Right now everything's a mess because it's going into the boat. This is the DC-DC converter, a Meanwell 650 watt rated 50 amp DC converter with a very wide input range, but it might be crap because it's so cheap, so it's probably going to break. This is our Soliton one. Very happy with that. Has a lot of cool settings as Jack has told you. Hey, so this is about it that we have going on right now. In about a week, we hope to make our first splash. So I'll update you as we build. Hey, you all still there? It turns out that my lead acid is just losing the war. There's just too much power in these batteries that Mr. Winston shipped us from China. And now the discharge has been reduced due to a volt limit. So we're above 14.6 volts. Maybe I should have set it higher. But I'm not sure. You know, I mean, I don't want to screw up the batteries in my setup. So it's limiting us to 26.8 amps or something on the discharge. That means that if I go to my cell tab and I'm still at 3.19 volt, it's gonna take a while before I have these 5 cells down to 2.9. Then I need to balance them. Then I've got another 18 sets of 5 to go because we have 95 of these batteries. We're at about, what is it now? 38,509. So we're at 38 amp hours that have gone out of these cells. I think that we're a little over half because I charged them a bit before we broke down the pack. So say I have probably about 50 amp hours in each one of these cells, maybe 60, who knows. So I need more power to come out of this pack, this lead acid pack that I'm charging into. Luckily, I have a bit of a converter going. So let's see if I can shed some light on this situation. Let's go back to the supply tab and check out that voltage number. Whoa! I think we're back to normal voltage, no limiting. That's pretty cool. I can hear the motor in the background losing RPM. And we're back to 0.5 kilowatt of regen. And I can see we're doing 30 amps of discharge current again. So how'd we do that? We had to add another set of jumper wires to this pack. This time it's connected to a 12 volt AC converter. That'll give us 250 volt, or 240, something around there. 600 watt max. And don't hurt yourself. Bit of a light. So, you got to keep on your toes to keep these batteries discharging. So much power in these lithiums. Don't know really where to put it.
So there's
That's
some
nice.
boating.
Yeah, there's some boating. Electric boats are pretty cool.
No, we're going to have trains, planes, and automobiles.
Yep.
It's kind of like a bad John Candy movie.
Yeah, like a John Candy buddy movie, huh?
Yeah, right. We're going to have everything.